All right, Owls, this is Mr. O with your first set of flip notes. Now, this first set of flip notes that you're going to do is going to be done in class. So it's going to be a little bit different than normal flip notes where you might be doing them at home or in a station in class. But this one will give you the idea of what flip notes are, how they're done, and how we will use them. You were given a note sheet. And you'll take the note sheet and you'll complete the note sheet as you listen to this video. Keep in mind a couple things with flip videos. One, if you have any questions, write them down. Two, the note sheet given to you in class will follow in order. And three, these are the general notes for the standard, meaning you should make certain that you're writing neat, you're able to read what you write, because this content will be what you use throughout this standard as we go. So this is matter 6.P.2.1. Remember, we did the matter major overview yesterday. This is one of three of those standards. And I'll come back to that matter major a couple times as we go through this video. Now, the big idea of the unit is that you need to understand the structure, classification, and physical properties of matter. That is all three matter standards together. This standard helps talk about the structure and some of the classifications and some of the physical properties, but not too many. Before we go any further, we're going to start with key vocabulary. Remember when we talked about the matter major in class yesterday? This is the key vocab. If you want to get a level 2, you have to understand these words upcoming for this standard. So by definition, you need to know the next set of words and what they mean to get a level 2 on that major. Also, you need to know and imply them if you want to get a level 3. And you have to extend and justify and design and enrich if you want to get a level 4. But let's get with the key vocab. This is where you get the words from. First one is matter. Obviously, if it's a matter unit, let's start with the word matter. And by definition, it's anything that has mass and volume. So if it has mass and volume, it is matter. The next is atom. I have a picture of an atom here. It's obviously not a real picture. Atoms are completely super small. You wouldn't get a picture like that of them. And they are small particles that compose, and the word compose means make up, so I put that in parentheses. All matter. So all matter in the world is made up of atoms. The next word that we're going to talk about is elements. Hopefully you've heard about a periodic table of elements somewhere in your life. There's one in the classroom on the back cabinets. And elements are made of atoms, and these atoms make up matter. If you remember when I read the standard to you yesterday, it talked about there's over 100 elements, just a little slightly over 100 elements in the world. And everything in the world is made up of these elements. So if you think about elements, the elements are the building blocks of all things in the world, meaning these 100 things, depends on how many there are in each thing, make things similar or different, which is kind of crazy to think about. Everything in the world is only made up of 100 ingredients. The last thing is molecular compound. In 6th grade science, you do not have to know the difference between molecule and compound. In 8th grade science, you do. It all depends on what type of atoms are coming together. If the top picture is not a real picture, but that is what water would look like. It's called Mickey Mouse. It's H2O. The two blue would be H's and the O would be red. And then in the bottom picture is actual legit picture of water. You can see the Mickey Mouse there in that illustration. But a molecule are two or more atoms joined chemically. A compound are two different elements combined together. The difference between the two is like the difference between an atom and an element. But just keep in mind, long as you understand it's when atoms come together, that's fine in 6th grade. I've had questions before, so that's the answer I put up there for you. The last of the vocab words is the word particle. And I have a picture of solid, liquid, and gases, which is actually the next standard. And we'll talk a lot about the particles in that standard. But these are smaller pieces of anything. And I put the word part there because if you look at the word particle, and a part of something is something smaller than that, it makes sense if you remember the word part and smaller. Now, flip it over on the back, and you're going to see this guy named John Dalton, and he had an atomic theory. Theories are things that have been tested over and over and over again. John Dalton's atomic theory When it was first started, had more parts to it over the years. Parts of it have been disproven because that's what scientists do. But most of his atomic theory holds true, and we use his theory to understand things about atoms that will always be constant. So he has 4 parts that I need you to write down of his theory that we need to learn about. First one is atoms cannot be broken into smaller pieces. Now keep in mind, they can be, meaning you can watch a scientist in a lab use lasers to take, you know, apart an atom from its neutrons and its electrons. But that's not what John Dalton was saying. John Dalton was saying atoms are like Legos, meaning you have some big piece of thing and you broke it down into smallest pieces, and if it was made out of Legos, you'd end up with one single Lego. What John Dalton was saying is if you took a hammer and smashed that one piece of Lego, you couldn't build that thing anymore. So he wasn't saying you can't break it into smaller pieces. He was saying atoms are things that when you break something down to its very smallest pieces, those are the things that still hold true for things that can be built. Number 2, in any element, all the atoms are exactly alike, meaning if it's carbon, all carbon are exactly alike. If it's hydrogen, all hydrogen are exactly alike. If it's oxygen, all oxygen are exactly alike, or gold or silver. That's what makes the periodic table elements unique, because each one of the elements are unique. Third part, 2 or more atoms or elements can combine to form compounds and molecules. It's showing how the world works. Atoms don't do anything until they start to combine and form compounds and molecules. And the last one, atoms of each element have a unique mass. What that means, if you look at the periodic table of elements, they have an atomic weight, and that atomic weight is different for every element, which makes each atom have an atomic or a unique mass found on the periodic table. At the bottom of your thing, I have these key points, and these are the valid statements that I try to help you connect key vocab terms together to help your better understanding of how the world works and how it's made up. First one is all matter is made up of atoms and molecules, meaning you can say all matter is made up of atoms. However, atoms don't build anything until they start to bond together. So it's correct to say all matter is made up of atoms. It's better to say all matter is made up of atoms and molecules. Different elements contain different atoms, meaning I have a picture here of hydrogen, helium, lithium, and sodium, all different elements. And you can see how they're all slightly different from each other. So everything on the periodic table has a different atom that makes it. Remember, there's only about 100 different atoms that make up the world. And then everything is matter except for energy. Keep that in mind. Energy is the next unit that we do in the second track-in, but matter is everything except when it comes to energy, and we saw that in our thinking probe today. All right. Any questions, write them down. I'll answer them in class for you.